We're gonna do rotations. So a rotation is a transformation in which a figure is turned about an axis point called the center of rotation. Rays drawn from the center of rotation to a point at its image from the angle of rotation. So if you guys notice a little diagram with the triangle and the line at the bottom right corner, we notice that you guys have point P as the center of rotation. As we have that image, we rotate it this way 40 degrees, but the only point that doesn't change is the center of rotation, which in this case is point P. Now you guys have two directions of rotation. You have clockwise and counterclockwise. Counterclockwise goes this way, and clockwise goes this way. You guys have in the classroom at the front, the clock is covered by a piece of paper, but if you guys can see the paper and you know the clockwise turns from the 12 to the right, then you'll be able to tell that clockwise is the top and counterclockwise is the bottom. Now, so you guys have an idea of that figure, we start with line right here, A. If we go about it to the first A, so A prime, that will be 130 degrees. Keep in mind, it is not starting at the axis. It started at an angle already. So that's why it looks like 130. It may look like a little more if you start from the axis, but it's not the case right now. Now, for the second, which is the A double prime, we start at the A. And we move 220 degrees to land into that new line. And then for the third one, H triple prime, we start at the A, take the whole rotation all the way to the end of that line, which is 310 degrees. Now, all of these rotations were counterclockwise. But if you wished, you could actually go backwards from here to here, and that will be a clockwise rotation from a different angle. I can't give you the angle right now as I don't know it, but that will probably be around 50 degrees of rotation clockwise. Now, these are the rules for rotations. The key word here is that it's a rotation about the origin. Now, when a point AB, what I've been doing for the previous classes has been X, Y, is rotated counterclockwise about the origin. The following are true. So for about a 90 degree, if we have XY, it's going to become negative Y, comma, X. For 180 degrees, it's going to go from X to Y. It's going to become negative X, comma, negative Y. And for the last one, which is 270, it's going to become from XY to Y, comma, negative X. It's just the rotation. You flip the letters, and then one becomes negative for, depending on the rule, for 90, the new X becomes negative, or the old Y. For 180, they stay the same, they just both become negative. And for the 270, the new Y becomes negative, or the old X. Now guys, in this one, they want us to graph the quadrilateral RSTU with the vertices R 3, 1, S 5, 1, T 5, negative 3, and U 2, negative 1. And they want us to rotate the image about 270 degrees rotation about the origin. Now I'm going to go ahead and write the rules right here on the left. So for a 90 degree, we go from XY to negative Y, comma, X. For 180, we go from XY to negative X, comma, negative Y. And for 270, we go from XY to Y, comma, negative X. Now having the rules right there, we can just rewrite the new points. Our new R prime is going to be, again, it's 270 degrees, it's given right here. So we're going to follow this rule right here. So our new R prime is going to be 1, negative 3. The new S prime is going to be 1, negative 5. The new T is going to be negative 3, negative 5. And the new U is going to be negative 1, negative 2. Now I'm going to go ahead and graph the original first. So this is our R. This is our S. This is our T. And this is our U. Now for the new one, I'm going to graph it in red, which is 1 comma negative 3. Then RS is going to be 1 comma negative 5. RT is going to be negative 3 comma negative 5. And our U is going to be negative 1, negative 2. So that's going to be a rotation of 270 degrees about the origin counterclockwise. For this next one, they want us to graph line segment RS with the endpoints R at 1 comma negative 3 and S at 2 comma negative 6 and its image after the composition. They want us to reflect the y-axis about 90 degrees from the origin. So we're going to use the rules. I'm going to rewrite them right here on the right. For the 90, so the 90 degrees is x comma y, the original, and it's going to become negative y comma x. I'm going to go ahead and graph the R and the S. The original R is at 1 comma negative 3, and the S is at 2 comma negative 6. Now, our new points, our new R prime is going to be 3 comma 1, and the new S prime is going to become 6 comma 2. So let's plug it in. This is the new R prime, and then our new S prime is right up here. Now, this is identifying rotational symmetry. I'm going to read it first, and then I'm going to explain it. So identifying rotational symmetry is a figure in a plane has rotational symmetry when the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. This point is the center of symmetry. Note that the rotation can be either clockwise or counterclockwise. So for example, the figure below has a rotational symmetry because a rotation of either 90 or 180 maps the figures onto itself, although a rotation of 45 degrees does not. Now guys, keep in mind this flower has like a 4-petal thing that's going on. We got 2 on the top and then 2 on the sides. And we realized when they rotate it to 45, we don't have that same shape. But when they rotate it 90 degrees, we do have that same shape, as well as 180. So for rotational symmetry, you want to make sure that that figure looks exactly the same after you rotate it. They're asking us if the figure has rotational symmetry. If so, we got to describe any rotations that map the figure onto itself. For the parallelogram, if you guys have on your test and your quiz and even on your iPads right now, you can actually rotate your iPad to notice that if you rotate it about 90 degrees, the parallelogram is not going to be symmetrical, as it's going to look funky, not going to look the same. Now, if you rotate it about 180 degrees, it is going to look the same. So yes, this one does have symmetry, rotational symmetry, 180 degrees. Now for the rectangular octagon, you can actually grab your iPad and do the exact same thing, rotate it about it, if you guys are not able to just see it, and you're going to notice that every 45 degrees, we are going to have rotational symmetry. So for this one, we do have rotational symmetry for 45, 90, and I'm even going to write in 180 because it's going to look the same no matter what. And then for the trapezoid, the only way we get rotational symmetry is when we do the full circle, and that is not rotational symmetry, as it needs to look the same no matter what, at least at 180 degrees. If it's anything bigger than that, then it doesn't have rotational symmetry.